Hello guys, welcome to my YouTube channel. So today I'll be dealing with the class 10 maths question, that is, prove that root 3 is irrational number. Irrational. So solution. First we will assume that, let us assume root 3 is rational. So students, we will solve this with the help of contradiction. So that's why we assume that let root 3 is rational. So to be a rational number, it should be in the form of root 3 should be in the form of a by b, where b is not equals to 0, and a and b should be co-prime, which means that the factors of a and the factors of b should be only 1. For example, suppose a is there 4 and b is there 6. Then if factors of 4 are 1, 2 and 4 itself, so the factors of 6 is 1, 2 and 3. So here these are not co-primes. 4 and 6 are not co-primes because the common factors are 1 also, factors are 2 also. So this is not the conditions of co-prime. So let this be equation 1. So what we can write this as, we can do cross multiplication and we can write a equals to, it will be like root 3 by 1, and a equals to root 3 into b. Now what we will do is that we will square it both sides. Squaring both sides, squaring this will be equation 2, as squaring equation 2 both sides. So squaring it, we will get like root 3b whole square. So a square is a square and root 3 square is your root 3 into root 3 will be your 3 only, and b square is b square. So we will get we will bring this 3b square this side, and we will just keep b square like this and a square by 3. So this will be our equation 3. So by theorem, there is one theorem called like by theorem, let p be a prime number if p divides a square. If p divides a square, then p divides a, where a is a positive integer. So what this theorem says is that, for example, if let p be a prime number, we will understand this with the help of example. Suppose 3 is our prime number, no, and if p divides a square, then suppose 6 square is your a, 6 is your a. Then if 3 divides a square, means if 3 divides 6 square is 36, no, so if 3 divides 36, then it says, this theorem says that 3 will also divide 6. If it divides its square, it will also divide 6. It means this theorem says that. So with the help of this theorem, what we can say is that, since a square is divisible by 3, no, so a is also divisible by 3, also divisible by 3. So divisible by 3. So we can write, so a is divisible by 3 means like a can be written as 3 into something, no, so something will be your c. Let us suppose that something will be your c, and c, which means integers, c belongs to integers. So substituting this, a will be 3c, no, let this be equation 4. So substituting this equation 4 in this in equation 3, we will get b square equals to, since our equation 3 is this is equation 3. So substituting the value of a equals to 3c in this, we will get like this. So which is equals to 3 square is your 9 and c square is your c square, and divided by 3. Here 3 1 is 3 and 3 3s are 9. So b square equals to 3c square. So we can write like this, no, 3c square is equals to b square, which implies c square equals to b square by 3. Here we can see that a is also divisible by 3, and this also says that with the same theorem, no, we can say that if b square is divisible by 3, then b is also divisible by 3 by the previous theorem, no. So we'll write like this. We can write b is also divisible by 3. Now see here, okay, here is no, a is also divisible by 3, and here what it is b is also divisible by 3. So a is also divisible by 3 and b is also divisible by 3. But this we have already assumed, no, like a and b have just common factors as 1, not more than 1, no. But here what we can say is that a and b are both divisible by 3. That means there are common factors other than 1 also. So what we can say from here is this since a and b have at least 3 as a common factor, but to be rational number, no, we just need a and b should have common factors only 1. But here we can see that 3 is also coming as common factors of a and b, no. So this contradicts the fact, but this contradicts the fact. And the fact, what it is contradicting, contradict means to prove that it is not true, to prove that it is false, no. It is contradicting the fact. What fact? That what we assume, a and b are co-prime. We assume that a and b are co-prime, no. But it is showing that a and b have at least 3 as common factors, so it is contradicting, it is showing that it is false. So what we can say is this contradiction, why this contradiction has arisen, because of our false assumption, false assumption. What we assume, that root 3 is rational. We assume root 3 is rational number, no. That's why it is contradicting. So we can say that therefore root 3 is irrational. So with the help of contradiction, we prove that root 3 is irrational number, hence proved. So this is very easy. Thank you.